Hi everybody. In this video, we're going to talk about mean and median, which are measures of center. In a little while, we'll talk about why they're called measures of center, but right now, let's just focus on how to calculate them. So we'll start with the mean. To find the mean, and by the way, another word for mean is average. So to find the mean or the average of a set of numbers, add the numbers up and then divide by how many numbers there are. Okay, so simple enough. So here we see we have a data set over here, a bunch of numbers which maybe refers to student test scores, or maybe it refers to how long it took people to complete some task, how many minutes. Okay, it could refer to a lot of things, but let's just focus on the numbers and calculating the mean. First thing we're going to do is add the numbers up. Okay, so let's just go ahead and add these up here. I'm just going to put plus signs between all of these. Okay, and we could do it by hand, but I'm just gonna go ahead and use a calculator for this. So we have 75 plus 50 plus another 75 plus 90 plus 100 plus another 90. If you have the same number more than once, you have to add them all up. Plus 70, whoops, what happened? Plus 70, plus another 70, plus 80, and we get 700 there. Okay, so that's the first thing to do. What's the second thing? Let's see, we add the numbers up and then divide by how many numbers there are. So how many numbers did we just add together? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so all of this is going to be divided by 9. So we're taking the sum. Ooh, that was so straight until right at the very end. So we're taking the sum and then dividing it by 9 because there are 9 numbers here. So this sum divided by 9 is equal to 700 divided by 9, which is equal to, and let's just divide that by 9 there. So you know what? I'm just going to round to the nearest tenth here. So that's a 7. The next digit over is also a 7. So this 7 is going to bump this 7 up. Remember, if you're rounding, then if the next digit is a 0, 1, 2, 3, or 4, the digit you're rounding to stays the same. If the next digit is a 5, 6, 7, 8, or 9, then the digit that you're rounding to gets bumped up 1. So since this is between 5 and 9, this is going to get bumped up 1. So we're going to say that the mean here is approximately, I'm going to use a squiggly equal sign, which means approximately, not exactly because I just rounded, it's approximately equal to 77.8. Okay, so that is mean. And by the way, something which I should mention, let me just do another quick example. What if I have, let's say, the numbers 4, 3, 0, and 7? Okay, what would the average of those be? Well, again, we would add them up. Okay, average being another word for mean. So we would add them up, and that would give us 4 plus 3 is 7, plus 0 is still 7, plus 7 is 14. And then we would divide by how many numbers there are. Now, the reason I'm giving you this as an example is because sometimes students will think that we don't count the zeros. So really, there are only 3 numbers here, 1, 2, 3, because you're not supposed to count the 0. But that's wrong. You have to count the 0, okay? So we have 1, 2, 3, 4 numbers here, okay? Even if there were more zeros, if it looked like this, now all of a sudden I have 6 numbers. So if I had something like that, then I would have to divide by 6. Okay, so you do have to count those zeros. I mean, they count just like any other number, even though they don't add anything to the sum. Okay, and let's just go back to what we had a few seconds ago. So this would be 14 divided by 4, which, let's see, 4 goes into 14 3 times with 2 left over. 2 over 4 is a half. So that's going to be 3.5 there. Right? You can say, if you don't believe me, 14 divided by 4 is 3.5. Okay, so that was just another example. So to find the mean, it's pretty simple. You add all of the numbers up, and then you divide by how many numbers you just added, okay? So that's mean. Now let's go ahead and do median. To find the median of a set of numbers, put the numbers in order from least to greatest, and then find the number in the middle. Okay, so this is something that we did not have to do for mean. The first step for doing the median is to put the numbers in order from least to greatest. You don't have to do that for the mean, because if you're just adding the numbers up, then it doesn't matter which order you add them up in. It doesn't matter if you add the smaller numbers first and then the large numbers, or you take a small number, then a large one, then a small one, then a large one. If you were adding the numbers up for the mean, the order that you add in does not matter. But for the median, we have to put the numbers in order from least to greatest first. You could also do it from greatest to least, but I'm just going to do it from least to greatest. So what's the smallest number here? Let's see, the smallest number is a 50. So let me put that first. What's the next smallest number? Looks like a 70. You know what, I'm just going to cross out the numbers that I already used. Okay, the next, well, there's another 70, so I do have to put that in as well. And the next smallest, 75. And then I have another 75 over here. And then what do we have? 80 is the next one. And then we have a couple of 90s. And finally, 100. Okay, I got them all now. Okay, now the next step is to simply find the number in the middle. So to find the number in the middle, what I like to do is I like to cross them off left, right, left, right, left, right, okay? So left, right, left, right, left, right, left, right, and here is the number in the middle. So our median, that's it, that's our median, it is 75. Okay, and now let's go ahead and scroll down. If there are an even number of numbers, there will be two middle numbers. You know what? Let me actually put this back on the screen. How many numbers were there here? There were 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 9 is an odd number. It's not divisible by 2. When we have an odd number of numbers, then when we do that left, right thing to find the number in the middle, there's no problem. There's just going to be one number in the middle when we are given an odd number of numbers. However, if there are an even number of numbers, so if the number of numbers is divisible by 2, there will be two middle numbers. And then to find the median, we would calculate the mean or the average of those numbers. So let's do an example of that. Here I have the same set of numbers, except I put an extra number over here, 93. Okay, let me just put that cursor over there. All right, so let's calculate the median of this set of numbers now. So you know what I'm going to do is just, I don't want you looking at that. We're finding the median of these numbers right now. First thing we have to do is put them in order from least to greatest. I already did that, so I'm just going to show you what that would look like. Okay, this is all of these numbers in order from least to greatest, okay? And the next thing to do is to find the middle one. So we're still going to do the left, right thing. Okay, so left, right, left, right, left, right, left, right. And you can see that now we have two numbers in the middle, 75 and 80. So we don't have two medians here. What we need to do is we need to calculate the mean of those two numbers. So just like we did before for mean, we would add the numbers up, 75 plus 80, would give us 155. And then how many numbers are there? 1, 2, not how many numbers are there in the entire data set. Right now we're just focused on these two numbers. So there are just two numbers here that we're calculating the average of. So we're going to divide this by 2. Okay, and let's see, 150 divided by 2 would be 75. 5 divided by 2 would be 2.5. So 75 plus 2.5 would give me 77.5, which, by the way, this number, 77.5, is halfway between 75 and 80. So it kind of makes sense for us to get that as a result. Okay, so not this, but this would be our median. Okay, again, we had an even number of numbers there. How many numbers did we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We had 10 numbers there. 10 is an even number. It's divisible by 2. All right, now just a quick warning. Even though I already mentioned this and it's right here, you do have to put the numbers in order from least to greatest first. A lot of students will skip that first step for some reason. It's not that hard of a step, just putting numbers in order, but they'll just take the original data set, like over here, these numbers are not in order, and they'll do left, right, left, right, left, right, left, right, and maybe find these two middle numbers and then take the average of those. The average of those, 190, would be 95. That's right in the middle between 100 and 90, but that would be incorrect, okay? And what's wrong is they didn't put the numbers in order first. So please remember to do that. Okay, so moving on now. I'm going to put this over here. And look what I uncovered. Okay, so this is actually a histogram of this data set. You can see I have 150 over here. I have 270s, like these 270s over here. I have, here's between 70 and 80, halfway between them would be 75, right? So I have 275s, I have 180, I have 290s, and I have 100. Okay, so this is a histogram of this data over here. And what I want to talk about next is that mean and median are called measures of center because they give results somewhere in the middle of the data rather than at the ends. Okay, so here is the data, and here we can see it visually on a histogram. And if you were to just use your eyes and maybe also your finger and just point to where the middle of those dots are, where would you point? Would you point over here? Would you say that this is the middle of the dots? No, this is all the way on the left side of the dots. Would you point over here and say this is the middle of the dots? No, that's all the way on the right side of the dots. You would probably point somewhere in this general area and say somewhere around here is the middle of the dots. Now, recall what we got as answers when we calculated the mean and the median of this data set. We said that the mean was about 77.8, which would be, if this is 70 and this is 80, it would be a little bit closer to 80, right? So let's just say around there. Okay, that was the mean, which was approximately 77.8, and the median that we got was 75, which is halfway between 70 and 80. Okay, so I'll just write it over here. So the median was 75. You can see that the mean and the median are pretty close together. They're not exactly the same in this case, but they're pretty close, and that often does happen. They're also where we would intuitively say is the middle of the data set. If somebody asked you, like I asked you a couple of minutes ago, to point to the middle of the data, the middle of those dots, then you would say somewhere around this area, and that is, in fact, where the mean and the median are located. Okay, so that's why mean and median are called measures of center, because they give us a value which is around where we would point to if somebody asked us to point to the center. Okay? All right, and note we're not talking about the middle of the number line here. So very often when I ask this question to students, forget about the mean and the median for a second. I'll ask them to just point to the middle of the data. I'll have students pointing right over here. And what they're thinking is the middle of the number line. So I have this number line going from 0 to 100, and 50 is right in the middle. But that's not what I'm talking about when I ask you to find the middle of the data set. I need you to focus on where these dots are. Okay, these dots represent our data over here, and find the middle of those dots. It wouldn't be at 50, that would be way up on the left side of our data set. It would be, you would point to around here, okay? And that is around where we find the mean and the median, and that's why they're called the measures of center. Okay, let's continue now. The mean and median are both pulled toward large clusters in the data. What do I mean when I say that? So let's look at some more data over here. And these could represent anything. They could represent student test scores. If they were student test scores, then this class didn't do so well. This class did a lot better. They might represent, I don't know, scores in a game. Maybe we had over here 4 people scored a 90 in some game. Over here, 2 people scored a 25. Whatever they represent, let's just look at the data. And if we calculate the mean and the median, you can see I already did it for you here. So for the mean, I added up all of these numbers. Okay, so 0, and then I had 1, 2, 3, 4 10s over there, and then 120, and so on. And I did add these up in order from least to greatest, but I didn't have to. I just wrote them in least to greatest because actually I wrote this first and then I just copied those numbers over to here. But anyway, so when we add those numbers up, we get 345, and there are 12 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Remember, we do include the 0. So there are 12 numbers, so 345 divided by 12 is 28.75. And then calculating the median, putting the numbers in order from least to greatest, then doing left, right, until we get to the middle. Since there are 12 numbers, there are an even number of numbers, then we do have 2 middle numbers over here. So then we have to add those middle numbers up and divide by 2, and we get 22.5, okay? So I calculated the mean and the median for this data set over here, and I also calculated the mean and the median for this data set. And let's go ahead and draw lines to where those are. So, well, first of all, actually, before I even do that, what do I mean when I say a large cluster in the data? If you look at this data set over here, where does it seem like most of the data is? Where does it seem like most of the dots are? Where are all those dots? Where do we have a lot of those dots and they're clustered pretty close together? Well, you would say on the left side over here. That's where we see the largest cluster of dots, right? For this data set over here, most of the dots are clustered on the right side over here. So when I wrote the mean and the median are both pulled toward large clusters in the data, that means when we go and calculate the mean and the median, we're going to find that they're pretty close to this large cluster of data. In this case, it would be towards the left. In this case, since the cluster is more towards the right, we would see that the mean and the median are more towards the right, where that large cluster of data is. So I calculated them over here for you, and you can see 28.75. Let's just go ahead and put that on the histogram here, or point to where it would be. So here's 20, here's 30. 28.75 maybe be right around here. Okay, that's the mean. 22.5 over here. All right, and for this one, the mean was approximately 71.71. So that would be right around here. And the median is 80, so that's right here. There's 80. Okay, so you can see that both the mean and the median were pretty close to that cluster where most of the dots are located, okay, in both cases. Now, something else that you might notice is that the mean in both cases, let me underline the means here. This was the mean for this one, and this was the mean for this one. So even though the mean, just like the median, is pulled towards the cluster, it's also pulled towards the tail. So this would, when we have data like this would be called skewed right. And that's because the cluster is on the left, but then over here we have what's called a tail, because it kind of looks like a tail going to the right. And that's why a data set like this is called skewed right. And you can see that the mean here is a little bit further to the right than the median. And that's because the mean is sort of, just like it's attracted to the cluster, it's also attracted a little bit more than the median is to outliers over here, to the tail of that data set. Over here, again, you see here's the tail going this way for this data set. And you can see that even though the mean is close to this cluster over here, it's also getting pulled a little bit further to the left than the median is, because this tail over here has more of an effect on the mean than it does on the median. And we're going to see why that is right now, actually. But for now, just understand that both the mean and the median are pulled towards large clusters of data. So if we see that there's a large cluster of data somewhere, then we can expect to find the mean and the median near that large cluster. But now I want to talk about why the mean is more attracted to the tail of this data than the median is. And it has to do with the fact that it's attracted to outliers. So that's what we're going to talk about next. So let's scroll down. Okay, now take a look at these two data sets. And the first thing that I'm going to ask you is, what's the difference between this set over here and this set over here? How is this data set different from this one? So pause and think about it for a second. Well, you might have noticed that really they're almost the same, except this point on the right has been moved from 60 in this data set all the way over to 100 in this data set, but everything else is the same. Now let's see. So over in this data set, this would be called an outlier because it's very far removed from all the other numbers in the data set. That's what an outlier is. It's just something which is very far away from all of the others. Okay? Now let's talk about how this outlier is going to affect the calculation of the mean and the median. Let's go back to this data set and calculate the mean. So what we do is we add up all the numbers, 30 plus 40 plus another 40 plus 50 plus 60, and divide by how many numbers there are, 1, 2, 3, 4, 5. Okay, so I did the calculation here. When we add the numbers up, we get 220. Divided by 5 would give us 44. So that's the mean for this data set. Now let's calculate the mean for this data set. And everything is the same. We have 30 plus 40 plus 40 plus 50, except for the fact that over here we had a 60, but now instead of 60, we have 100. So this part of the calculation is different, and since the number over here is greater, then when we do the sum, 100 is greater than 60, right? So then when we do the sum, in the numerator here, we're going to get a number which is greater than what we got before. Back here, we got 220. Now we have 260 in the numerator, but the denominator has not changed. There are still 5 numbers, okay? So the denominator in both of these are 5, but the numerator is bigger. And what happens when you take a bigger numerator, a bigger number in the numerator, and divide it by the same number that you did before? You're going to get a bigger answer. So now instead of having 44 as the mean, now the mean is 52. So changing this 60 to 100, right? So moving that data point further to the right also made the mean greater. It changed it from being 44 to now being 52. Now let's see what effect moving this point from 60 to 100 has on the median. Well, when we calculate the median, we put all the numbers in order from least to greatest. So 30, 40, 40, 50, 60. That's these numbers over here. And then we just cross them out left, right, until we find the number in the middle. Here there's an odd number of numbers, so there is just one middle number. So that's good. It makes it a little bit easier. And that number is 40. So 40 is the median. Now over here, when we calculate the median for this data set, instead of having the 60 over here, like we had in the first data set, we're changing that 60 to 100. So you can see that 60 has changed to 100, but everything else is still the same. How is that going to affect the median? Well, let's go ahead and just cross things out. So we're left, right, and look at this, the median is still 40. So changing this point over here, moving that 60 all the way over to 100, it didn't affect the median at all, because all we did when we calculated that median is we crossed it out, right? Even if we had moved this point all the way over to 1,000,000, right? Let me change that 100 to 1,000,000 now. Would that affect the median? No, it still wouldn't affect that median at all, because when we go to calculate the median, all that's going to happen is that number is just going to get crossed out. Well, and we're just looking for the number that's in the middle. So outliers really don't affect the median, but they definitely do affect the mean, because we actually do have to add them up in that first step when we're calculating the mean. Remember, when we have to add everything up, changing this 100 to 1,000,000 is definitely going to affect the outcome of this calculation over here. If I do 30 plus 40 plus 40 plus 50 plus 1,000,000, then I'm going to get some big number here in the numerator, right? And then divide that by 5, I'm still going to get a very big number over here. So having an outlier, it will affect the mean, but it's not going to affect the median. And that's why we can see, going back to the last example that we did, having a tail where the numbers move really far in one direction, it's going to move that mean further in that direction. If we were to take one point and move it really far away, then the mean would follow, but the median would not. Okay? All right, so next, here's what I want to talk about next. Mean and median are often near each other. I think we've seen that in these examples. Very often, the mean and the median have been pretty close together, like 44 and 40, pretty close, right? But they're not always exactly the same. But they are exactly the same when the data is symmetrical. Okay, so here we have an example of data which is symmetrical. What does that mean, symmetrical? That means I can take a line and go through the middle of that data And it's sort of like a mirror where everything on this side is exactly the same as everything on this side. So this is like the mirror image of this, or if you want to say the other way, this is the mirror image of this, right? Like looking at yourself in the mirror, you see exactly your own face, you see yourself. Okay, so this data is symmetrical. It's the same on both sides, exactly the same. And when that does happen, then the mean will be exactly the same as the median. Okay, and you can, I didn't go through all the calculation here, I didn't put it all on the screen. You can do it if you want to. You can add up all of these numbers, okay, and you can then divide by how many numbers you have and calculate the mean. You can put the numbers in order from least to greatest and find the middle one, and that'll tell you the median. If you go ahead and do that, you're going to find that the mean and the median are both exactly the same for this data set, and that always happens when you have a data set which is symmetrical, when you can draw a line through it somewhere and both sides of the line look exactly the same. And furthermore, it's not hard to see when you do have a symmetrical data set what the mean and the median are. You just have to look for the point of symmetry, okay? And like I said before, if we draw a line down here through 70, then the left side looks exactly the same as the right side. So 70 is the point of symmetry for this data here, and the mean and the median would be exactly 70. Okay, if you don't believe me, then you can calculate them yourself using these numbers over here. And even if we did not have this point right over there, the line of symmetry would still be over here. And even without an actual data point being at 70, the mean and the median would still, when we calculate them, it would still be 70, exactly where the point of symmetry is. Okay, let's see what's next. Okay, so moving on, if two sets of data are very far apart, we can visually determine which data set has a higher mean and median even before doing the calculations. All right, so this is a very important point. I'm not going to calculate the mean and median right now, and I don't want you to calculate the mean or the median either. I want you just to take a look, just look at it, okay? Just use your eyes for a second. Look at this data set over here, and look at this data set over here, and I want you to keep in mind that mean and median are measures of center. So when you're looking at these data sets, I want you to think of where the center of this data set would be. It might be a little bit different for the mean and the median, but just roughly speaking, if you were to take your finger and somebody asked you to point towards the middle of those dots, where would you point for this data set, and where would you point for this data set? Where would the middle be for those two data sets? Okay, and by the way, both of these data sets are also, the number lines are always also the same. I have them both going from 0 to 100, both of these number lines. Okay, so I want to ask you now, which data set has a higher mean and median? And I want you to answer that question just by looking at the data without actually doing the calculations. For which data set is the center higher? Okay, hopefully you were able to determine, even before doing any calculations, that the middle of these dots is right around here somewhere. Okay, I'm not going to say it exactly, like right in this general area is the middle of these dots, right? So somewhere in the 80s, let's say. The middle of these dots looks to be about here somewhere in the 20s, right? Okay, you know what? Instead of a blob, I'm going to do it this way. I'm going to draw a line through where I put that blob before, and I'm going to make it go down really far, even down to this number line over here. And instead of the blob that I had over here before, I'm going to draw a line there. Okay, just like that. I can see that this line, which shows me where the middle of this data set is further to the right than this line, which shows me where the middle of this data set is. And therefore, just by looking at it with my eyes and just pointing my finger at where I think the middle of that data set is, I can see that this data set has a larger center, a higher center, right? A center which is further to the right than this data set. And that's good enough for me to be able to predict that when I do calculate the mean and the median, I'm going to see that the mean and the median are higher for this data set than they are for this data set. Now, I already went ahead and calculated the mean and the median, and here they are. For this data set over here, the mean is approximately 86.7. If you actually do it 70 plus 80 plus 80 plus 90 plus 100 divided by 6, you would get a repeating decimal. So it would be approximately, I had to round, 86.7. The median would be at exactly 85. For this data set, the mean is 25 and the median is also 25. Actually, take a look at this data set here. What do you notice about it? It is symmetrical, right? This line here, it's not just where the center is. That's a line of symmetry. To the left of this line looks exactly the same as everything to the right of this line. So when that does happen, remember the last thing we talked about, when a data set is symmetrical, then the mean and median would be exactly the same. All right, but moving back to this point over here, just by looking at it, we were able to predict that for this data set, the mean and the median would be higher than for this data set. And in fact, that did come true. 86.7 is higher than 25. So the mean for this data set is higher than the mean for this data set. And 85 is higher than 25. So the median for this data set is also higher than the median for this data set. Okay? Now, do keep in mind, we were able to do that because these data sets were very far apart. If they had been somewhat closer together, so let me just move these points further to the left, let's say. I'm going to keep this one where it is, but I'm going to move these points further to the left. So now they're a little bit, not a little bit, a lot. Now they're a lot closer to these data points over here. Then it would not be as easy to tell just with our eyes which data set has a higher mean and median. Okay, but when they're very far apart, then we would be able to do it just by looking at it. All right, so I'm going to end the video there and have a great day.